Okay, I think we reached critical mass. So welcome to our 11th and vorletzte lecture for distributed information systems. Idea for today is continue with what we started last week. So SOAP-based web services and then switching to REST-based web services. And after that, we are nearly through with the content of this lecture. So basically for tomorrow is talking about the rest of the stuff we skipped over due to the exercise aspects. And then we still have some time to talk about the XM. And I took a look at the XM last week, or the XM from last year, which will be basically quite similar than this year's XM. And there will be no direct programming as far as I have seen. So you don't need to program any working code. Nevertheless, it will be possible. It is possible that there will be some code sequences which you have to take a look at and tell me if it's working correctly or what would be the output and stuff like that. So no, you do the coding, but nevertheless, you need to know how to deploy a web service, for instance, and how to trigger a web service, how to access the content of a REST-based web service and stuff like that. So basically all that what we practiced in the exercise can in some way pop up in the XM, not in a you do the programming aspect, but in, okay, if you see this sort of code, is it running smoothly, or what would be the output if this is the input and stuff like that. Some multiple choices, some open questions, some yes and no questions. And as I already announced multiple times, it will be an online XM and it will be based on Moodle, and it's more or less randomized. So typically I have a pool of questions for every XM question, and the Moodle algorithm tries to calculate or calculates for every student her or his own XM. And we will have the opportunity to talk about that on Thursday in more detail. And yeah, that's basically the idea. So today is a slight reintroduction what we did last week. So talking about the SOAP-based web services, and then moving on to the REST-based web services. And then we are nearly through with the content of the exercise and of the lecture. So let's see, where did we stop last week? I have to move it here, and I have to share my screen. Share screen, which screen? That one, let's share this one. So let's see, this was where we stopped last week. Perhaps as I realized that not all of you, that we have split up quite heavily. So some of you haven't finished with the second exercise in total yet. Some of you have already started or are well through the third exercise. So there is a huge heterogeneous array of people doing stuff. And that, of course, is a problem helping all of you in the same amount. So let's see. One aspect, if you haven't started with the JAX-B, or if you're still working on the JAX-B exercise problem, which is this automatic conversion from a Java object or This works for every programming language or every sophisticated programming language. There is a mechanism like this. You have an object, class definition, and then you can use some kind of API to convert this or convert objects of this class into some kind of export format and backwards, just by calling a specific name, marshal, unmarshal, transform, untransform, parcelable, unparcelable, stuff like that. So that's available in nearly every sophisticated programming language because it's very attractive to exchange data. If you don't have such a mechanism, you have to do it all by hand. And as we realized when we were playing around with sockets, doing everything by hand on a very low level layer, then of course we open up lots of problems and it's quite heavy workload. So doing stuff with the use of an API is very attractive from a time point of view. And this JXP, of course, is the API that can be used to transform Java objects into XML and JSON. And this is what we want. And this is also what we need later on when we want to use SOAP and REST-based web service, because SOAP especially is very XML heavy, and the REST-based web services are quite JSON heavy. And therefore, the conversion of objects into this kind of format is attractive to us, or for us, attractive for us. So, and what I wanted to show you, because that was something a few of you ran into, was you will start doing the XML stuff. This will be rather smooth without any problems. And then the next exercise part will be doing the same with just supporting JSON. And then you will switch from the typical Java, basic Java libraries to these Moxie libraries, and slightly adapting the code. And what needs to be taken or considered is that you need to integrate. Classic example, that's still JXP, blah. JSON, here we come to JSON, how to build JSON, very attractive JSON. And then we come to the Moxie libraries. And then there is these JXP, and of course I have a note here, which I'll just move slightly to the side. So this is something you need to consider, because even so we have a version change, this needs to be integrated in some kind of way. So when you're doing the JXP stuff and switch to the Moxie libraries to support conversion into JSON, then you have to integrate this use of the JXP context factory. And this can be solved in different ways. One way is you provide a JXP properties file at the same level where your objects reside, where your classes resides, which need to be serialized and deserialized. I'll show that in a moment or two in my source code example. Or if you don't want to integrate an external file, you can set a specific system property before calling the construction of the JXP context class, which contains the same content, but is slightly more flexible in my point of view. So this needs to be considered. So slide 78 is important. And if you start working with non-root objects or segments of specific XML or JSON content, you need to remember that this slide is important. So 83 is also important, because this is are relevant when you have, if you want to work with content that has no root information. And then you need to be more specific into which object the content needs to be converted. And then you have to use this alternative unmarshal method down below here. So 83 and 78 of slide package 7 are relatively important when you want to do the last thing of the first exercise on the third exercise sheet. So when you switch to JSON, this becomes important. What I wanted to show you was, so I can close that and we go there and we have this here. And this is JXBWS. This is what we wanted. No, we wanted this JXB, JSON source stuff. No, it's not in there. And perhaps here. Yeah. So in this example, what can we see? Lots of unmarshallers, sensor values which get transformed, the container of the sensor values, and this JXB property, which just tells the system which context factory to use. This is one way to do it. And did I integrate this in a different way? JXB context? No, I didn't. Oh, I didn't. So it's just my try to solve the exercise code over here. Now, but this is necessary or might be necessary when you do the Moxie stuff, but you will find out. Question, Mr. Stein, Mr. Oehner?
Yeah, it's just a file.
It's just a file. You should create it, or you can use the alternative approach and not use a file. 78, and you just put this line of code in front of before you generate the context. So this would, in my example here, would go into line 62, and then it would also work. Okay.
Okay.
Fine. So this is relevant if you're not already finished the JXB stuff. So next step would be doing the SOAP-based web services. So we can close that and we can open that, save changes. And we open that. And the last thing we did last week was to show you how to download the WSDL file, because that is important. In this, on the third exercise sheet, the second exercise is playing around with SOAP-based web services. And of course, we start with a dummy server, a Hello World SOAP-based web server. And on that dummy server, we use two approaches. We use a static approach and a dynamic approach, meaning the static approach is you build the class files before you use them on the client side. So it's always the same problem. You have a remote procedure call or remote method invocation on the server side. You do all the implementation, you define the interfaces, and the problematic part is the client side. The client side typically only knows the interface, and using the interface and some kind of logic, the client is able to construct the classes that are necessary to enable into communication with the server side. And this is able to build is on the RME stuff. It talks to the registry, and the registry makes sure that the code that is necessary is reloaded over the network from the server side and brings it to the client side. The problem with the remote procedure calls is that we don't have this RM registry. Therefore, we have two possible ways. One, as I already said, is the static one, where we not only have the interface, but also have the classes available that are necessary to realize the stub on the client side. So in order to build these, we have to get our hands on the WSDL file of the server side. We download, we store the WSDL file of the server side, then use a specific compiler that is able to read the WSDL file and construct some matching classes out of it. And this will be the static one, which we will take a look at in a minute or two. And if this works, then we know, okay, in principle, the communication is possible. And the next step, the more sophisticated one, is just using the interface classes on the client side and doing this construction of the matching stub classes on the fly while calling the web service without any pre-construction of any classes. And that, of course, is quite attractive because the only thing you need to know is the interface, and with the help of this interface and where to reach this SOAP-based web service, you are able to construct methods and classes that are able to communicate with the server backend without any doing. And this is what we want to do. So this is our goal. And in order to reach that, we had to build a web service. We already talked about the SOAP-based web service construction last week. A small recap, nevertheless, could help, because typically we forget what was yesterday, and remembering last week is even harder. So what we need to do is we need to, again, use some kind of annotations and lots of libraries that use these annotations to build whatever we want, whatever we need. Most important annotation is web service, which marks a specific class as a very specific web service. For the static approach, where everything is pre-constructed, the annotation web service alone is sufficient. And once we want to do the fancier approach, where this pre-construction is dropped and everything is done on the fly during runtime, we need to specify a specific endpoint interface. And so this is an example for the more sophisticated approach. Without this endpoint mechanism, then this would also work nicely for the static approach. So web service is one important annotation. It is important, or it is used to mark a class as a web service endpoint. And the second important one is the web method, which marks the methods, the remote procedures we want to call. So every method we want to be accessible through the use of the SOAP protocol needs to be marked with a web method annotation. Of course, you can mark a class as a web service with specific web methods that can also contain dozens of non-web method methods. So web method is only marking those which should be publicly available and reachable from the outside in form of a remote procedure call. Parameter as a result, one way. There are a lot of additional annotations to fine-tune the behavior. Typically, you want to have things slightly more fine-tuned, and of course, these are also available. But for our little practice exercise, these two are sufficient. So this is a very simple example of a dummy server, a Hello World web service from the SOAP-based world. All we need to have is we have to specify a specific class, mark it as a web service, mark every method we want to be reachable from the outside as web methods, and that's basically it. Taking a look at this example, the say something web method, of course, is the most simple one, because it only uses specific, or it only uses Java native types. And these, of course, are all supported by this mechanism. The problem resides in the second method we want to export and make publicly available through the SOAP interface, because here we have a return value that is not basic Java type, or a basic Java type, or not a native Java type. This dummy data is our own type. And in order to have this working, of course, this result here needs to be converted into XML. Otherwise, this would not work, because SOAP is completely expressed in XML. So the return value, of course, needs to also be converted into XML. In order to have this working, we again use this JAX-B mechanism. So all we need to do in order to have this working is use the results of our last exercise and annotate dummy data appropriately, so it can be converted using JAX-B. And as we already experienced when we played around with JAX-B, or some of you will do that today, it's not really that complicated. All you need to do is annotate the relevant elements you want to have converted, and then everything else runs automatically. So we need to specify what is the root and what parameters, what properties of this class are part of the export and import chain. And in this example, every property of the dummy data is used on that behalf. Something you will experience when you do this conversion is, that's quite interesting, and you will have to look that up later on. This example here, the toString method is provided overridden. So dummy data on the server side provides a toString method. And you will see that when you do the dynamic conversion and access from the client to the server, suddenly this toString method is not available anymore. And of course, there is a good reason for that, because in this dynamic approach, dummy data is automatically constructed by an external compiler. And of course, this toString information is not available in this conversion, in this compiler mechanism, because the WSDL file, which is used to specify what's the content of dummy data, only knows about the marked elements here. And therefore, the toString method is not constructed. And this typically is a surprise for some of you, because you programmed the toString method and suddenly it's not available anymore on the client side. How can that happen? And the reason is that on the client side, a secondary dummy data gets constructed, but it's not the class you designed, but it's the class the compiler builds, because there needs to be a class named dummy data which contains string mtext and long mtime. And of course, it doesn't know that there should also be a toString method available. But this is something, if you take a look at what gets constructed. Right, then we talked about how to set a specific SOAP-based web server online. And there are different approaches to do something like that. Of course, always multiple ways to solve the same problem. And we will use the most easy approach, which is the use of the endpoint class. So this line, these few lines of code are sufficient to build on your machine a SOAP-based web server on and put it online. So after that, on localhost 8081, with the URL attachment hello world, there will be a specific web service reachable. Of course, hello world is freely choosable, so you can use stuff if you want to. We can do that by just taking a look at that. So Jax web service main, and we can change that here to start. That, execute that, and then server is up and running. We open up the browser that pops up above here, so we move it down here. Then we choose localhost 8080 is of course not correct. 8081 not found. Yeah, but it's definitely else, and we use stuff. And then you see, okay, I can reach my web service. And the important thing is using the WSDL. As I also introduced last week, sometimes depending on the implementation of the libraries, and this is typically different between Linux, iOS, and Windows, this information page is not provided. But if this is not shown and an error is shown, it may still be fine. Everything may still work. And if you extend your URL with a question mark, oops, come here. And then you should be provided with some XML content in your browser. And this XML content needs to be stored. Again, careful by doing copy and paste. So you could mark everything and then try to copy it to a file. May work, may sometimes not work, because some of these browsers integrate these nice little macros here to better play around with the XML stuff. And some of them are copied as well, but are not part of the XML file. Better go to the source of the page, and then you can mark everything, copy it, and move it to some kind of file. So you can move here back to a file, and then you can store that as a WSDL file, because we need that. And as you can see, the location, how to reach the web service, is also encoded in here. And this WSDL file is important for the next step in the exercise, in order to build a client and make this server reachable from the client side. So that is one thing, and we can close that now, and we can close that here, and we are back here. So this is important, and if you can reach the WSDL file, you know, okay, the server side is up and running, everything is fine. And of course, then the next step is storing the WSDL file. And then if you have the WSDL file, you can use that to construct the client side. Something we will use, or some of you will use, some nice little browser plugins or some external programs to play around with this REST-based web services and SOAP-based web services. But you can also use something quite primitive if you want to say some command line tools, which are also capable to support you playing around with the exercise. And one of the very powerful and very and available on nearly every machine is this curl program, which is tiny, command line based, but very powerful, and you can nearly do everything with that. And it supports nearly every protocol and every platform, and that makes it quite attractive, if you want to say so. And of course, with curl, you can also reach your web service once it is online, and you can use curl to store the WSDL file if you want to. So with this command on the bottom here, and the program is curl installed, you could execute and store the WSDL file. We can try that here. So curl, okay, curl, and then we try to reach HTTP column localhost 8081 and stuff. When we do that, you see then there is some kind of information provided. It's basically the table we saw on the web page. And if we do that with a question mark, yes, DL, and then you see the WSDL file communicated. And with the -O, and then it would store it in the current directory. And of course, you can fine-tune that if you want to. So for this exercise, curl is also useful. And it is also useful for the third part of the exercise. Once we reach the ability to generate and start up REST-based web services, because what we can also do is we can, of course, also manipulate the headers of the HTTP call. And what we will see later on is when we play around with REST-based web services, we have different ways to follow a specific branch, URL branch, on a REST branch. And this could either be directly expressed in the URL we are choosing, or we could manipulate the branch by telling the server side which type of data we are capable to process. And in order to manipulate the header, we can just say, okay, what type of content do we accept? So this curl call says the client browser only accepts plain text. And so the REST-based web service that is hidden behind this URL is realizing, okay, I cannot send XML to that one. So let's choose the method that is annotated correctly to provide plain text. And the same goes for XML and JSON. And these three are the typical approaches. But we will talk about that later on. And of course, you can post some data. So in this case, this XML fragment here, which is of course huge, but you can extend that to your liking, is sent to this REST call in form of a post HTTP request. And so this content is provided to this method and can then be analyzed and integrated into the reply. But we will see that once we reach the REST mechanism. So what we are capable of now is we can build a SOAP-based web server. So we have the server side. The server is up and running when we can extract the WSDL file, and that we are capable of. And now we come to the client side. We want to use the methods that are provided by the server and use SOAP to express our wishes. And as I already told you and explained, we have two versions or two variants to do something like that. We have variant A, where we pre-generate all the necessary classes that are necessary on the client side and use them in our source code. So we extract the WSDL, use a WSDL compiler, which then analyzes the file, builds the classes that are used in the interface. And these classes that are constructed, we then use in our construction of the client. So we do that before we code the client. And when we have these constructed classes available, we code the client side, telling the client, okay, calculate something, do something, and then use these classes to call the method of the server side. This is the variant A, which I called static in the beginning, because it's not very dynamic. We construct these classes before we start coding. Variant B, on the other side, is the dynamic version, where we just know the interface of the server and we know the address of the server. And then this construction of the classes is done in the background and fully automatically. So you just know the interface, you tell the system, reach this server which uses this interface, I want to call this method. And in the background, the system automatically grabs the WSDL file, analyzes it, builds the class files, uses the class files, and you don't see anything at all that this is happening. And that's also the reason why we practice both versions, both variants, because I want you to see what is happening in the background. So how many classes are constructed, that there is a lot of processing power in the background we don't see anymore when we use this version B mechanism. And that's the reason for the structure of the exercise. So we grab the WSDL file from the server, and then we use a specific program. It is called WS import. WS import once was part of the SDK, so when you had Java installed, you could always use it. The problem, of course, is with this size reduction of the JDK and all the fancy libraries dropping out of the JDK, this WS import also has been dropped out. So it is not available anymore. Nevertheless, there are, of course, specific libraries that provide this WS import. And on the Moodle platform, there is a specific JAX WS-RI archive, which you should download and use. And in this, if you take a look at this JAX WS-RI, you will see that there is a binary directory, and that there are that this WS import is a batch file, a shell script that you can then use to do the job. So all you need to do is download the zip archive from the e-learning platform, extract it at some point on your computer, make sure that the libraries are and the binary directory are inside the path. And when this is conducted and you can start up WS import, I'm not sure if I did that last time. WS import. Now it's not recognized. Where did I put that? Workspace 3D. Komm her hier. Da. Module, wie habe ich das denn genannt? Module, Libraries. Wenn ich da mal dran erinnern würde. Wenn ich mich da mal dran erinnern würde. Java Modules, glaube ich. Modules, CD, JAX. Da will ich rein. So, dann ins Binary-Verzeichnis und da sehen wir das. Now we can see there is this WS import. So I can use that WS import. And when you are able to have this output, then you know the compiling will work. Then you just need to use this parameter string. So what do we find? -d marks the destination directory for the generated files. And you have to be extra careful with this one. Extra careful with this one. I explain in a minute or two why that is the case. Minus keep means there are two ways for this construction. One is typically it generates the Java files, compiles the Java files, and then gets rid of the Java files because it only needs the class files for the execution. But we, in the static approach, want to use the Java code as well, so you can integrate the constructed files into your project structure, and therefore we have this keep the Java files. Minus P is defining a package structure, so the constructed files that will be dropped into a specific directory have a specific package structure, and the WSDL file, which is the source of the information. So you will do that. And what can happen is if you have everything in one project, in one module, then you store the WSDL file in your server directory. Then you do this WS import call, and then this system will automatically construct classes that are named inside this description file. And it will store them inside this directory. And if your server classes are also in this directory, they will be overridden. So everything you programmed is lost. So you have to be extra careful that this directory is pointing at the client side and not at the server side. I had dozens of students who killed their source code by choosing the wrong directory here. So extra careful. And that's also the reason why I want you to split up everything into modules, projects, whatever. A project module for the server, a project module for the client, and a project module for the interface. And when this source directory is pointing at the client side, nothing bad can happen. If this is pointing at the wrong directory, you lose your source code, because then what is stated in here will be used to write same name, class names into this directory. And then everything is lost. Yeah, how to use this content I already expressed. And if you're able to do this call, so batch file or shell script, then you already won. And you are able to construct the static approach. So what will happen is that the system generates lots of files, and I did that on Friday, I think. Let's see. So we did that. And where did I do that? Dear, and where did I put that? Im Gedächtnis wie ein Sieb. So, temp. No. Yeah, there it is. So I did that on, as you can see, on the 14th of the 1st. So, and then I dropped it into source. And okay, I used the AA and BB and C. Shouldn't use AA, BB, and CC, but that should be clear. And what you can see is what the system does when you compile this WSDL file. You get classes and you get data response, hello world service, object factory, say something. So all the methods you want to use suddenly become classes. And these classes can then be used for the construction of your client side. So the client that is capable of calling a method on your web server. That is the idea. So you use the Java classes that are incorporated here and integrate them. You can either construct them in the right directory of your client side, or you can just copy paste them into your client project if you want to be on the safe side. And once you have them constructed and copied into your project, then you can use that on the client side to call the server. And all you need to do is you need to build an object of the service class. So remember, this was the name of the WSDL file. And I'm not 100% sure if you manipulate. Yeah, it will be. You will see what service class will be constructed, and you use that one. And then you have to use the object that is popping out of this construction and use the get name of the web service trailing port to get an interface of the web service. And then you have in this hello world interface contains all the methods that you told the system to make available on the web service. So that is all the web methods are defined in this interface, and then you can use them, and then you can call them, and then you can work with the server. And that, of course, is part of the exercise. This brings us to the dynamic approach. So the dynamic approach is not pre-compiling the stub on the client side, but letting the system do it automatically in the background. In order to have this working, the web service must be announced with this interface specification, the thing I told you about with this web service annotation, and now you need to specify this endpoint. Otherwise, it will not work. And every non-Java return type needs to be serializable by using XML. And the interface and parameter classes need to be known on the client side. So the interface and dummy data need also be available on the client side. Otherwise, it will not work. So everything that is used inside the interface must be globally known and therefore be part of the interface specification. You can export that as the jar file and then import that in the project, aside from all the other libraries that are necessary for have this working. Yeah, basically that's it. All you need to know, all you need to use on the client side is you need to know how to get the WSDL, how to reach the web service, and the qualified name of the service endpoint. So the knowledge about the interface, which is globally known. So that's basically also known to you. And with that, everything should be working. We will use a few classes, namely the service class and the QName class, which are used to define the specification. So to have our dummy example be dynamically reachable, we have to go away from this web service without an endpoint specification to a web service with an endpoint specification. So this is necessary for the dynamic approach. And of course, Hello World needs to implement the iSimple interface afterwards. That's basically everything that changes regarding the static and the dynamic approach. And of course, this dynamic approach also works for the static conversion, but it's just one step further. And in order to reach or to use that, we don't use these classes directly anymore. All we need is we need to have a service object which we want to use. And in order to have a service object, we need to provide the URL where to find the WSDL file. So what we used in the first example in the static approach to get our hands on the WSDL file, this is necessary. And we need to know the service class. And you have to be careful. This is the name of the web service. And this service here is a trailing add-on. This is especially important if your web service is called environment service. Then, of course, the string that is used here is named environment service service. So the trailing service always needs to be added. Another thing that is important is this one here, this URL, this stuff here, is the package structure of our service here in reverse order. So this is also important. So this needs to be reverse order package of this web service here. And it is that important that you always have a package structure. I told you that multiple times, and I tell you another time. So that is the important thing, and that is all. So now you have a service described, and once this object is up and running, it automatically constructs everything that is necessary to do the method calls in the background. So after that, you can use the service get port with the help of the interface class which you're targeting. So you want to have a specific, you want to have an instance of this interface, and this interface pops out here. And with mSOAP, you can then call every method of the SOAP-based web service. And that's not much code that is necessary to have this kind of power. Okay, and that is all that is necessary to do the trick of the second exercise on the third exercise sheet. Taking a look at the clock, we are a little bit trailing behind, so we will make a 5-minute break. So 9:50, 9:51, we will continue, and we will continue with slides, and we have exercise, and we have exercise sheet 3. There it is. And after the break, we take a look at the third exercise of the third exercise sheet, which is playing around with REST-based web service. Correct. Yeah. So short break, and after the break, we take a look at the last exercise part that is available. This is still that, and here comes the third part of the exercise. Okay, see you in a minute or two. And then the REST-based web services. Right, back again. So let's check. Let's continue. Okay. So next step, last exercise. By the way, so the upload for the last exercise, of course, is end of Thursday. The first deadline. But I set a second deadline when the upload really closes to Wednesday next week at 5 o'clock, 4 o'clock or something. So you can still upload the results till Wednesday next week, because for some of you, getting everything done till Thursday by doing own coding might be a little bit too much workload. So you got all the weekend and Wednesday till Wednesday to upload everything, and you can show me your results on Wednesday as well. We can make an appointment on Wednesday. If there are many groups that need to present on Wednesday, we have to make an official appointment, but I want the group leaders, die Sprecher, group talkers. Nah, it's not right. How are they called? Can't remember. The leaders of the pack to give me a call regarding the presentation if necessary. Otherwise, I will have to make one up on my own. So if we do the REST-based web services, we again need lots of external libraries. And again, they are available on the e-learning platform, so don't play around too much. You can, of course, search for your own set of libraries, but with the libraries provided of the e-learning platform, everything should run smooth. When we have that up and running, what do we need? Of course, we start again with a Hello World example of a web service. So you build a Hello World dummy REST web service that is reachable and that provides different output elements using different URLs. And as I already told you, you can achieve similar result by providing different HTTP headers. So in this case, you tell the system, okay, I want to follow this URL path, and this URL path leads to a JSON output be provided. And this, of course, for an XML output, but you can achieve the same thing by stating in the HTTP request that you only understand XML, that you only understand JSON and plain text or standard HTML, stuff like that. But we will take a look at that in a moment or two. When this is up and running and working smoothly, then you should build a REST-based environment data server. So an environment service. And what we want is that if we call this URL, we get an overview HTML page. If we use this URL, we get a list of supported sensors in XML or JSON. You can state it here XML, but you can also use JSON, of course. And if you use a similar URL, but with the name of a specific sensor, then you get the XML serialization of a sensor compatible env data object. And again, we have an all URL where all the elements are provided. So we provide a similar interface to that one, which we have already supported in C++, Java RMI, SOAP, and now on the REST world. Slightly different because REST is not really looking like a remote procedure call. Nevertheless, we can, of course, do the same stuff by slightly adapting it. and the service should support randomly generated temperature and humidity values. And you should use a browser, curl, or SOAP UI, or whatever mechanisms you know of to check the different URL branches and experiment with the output. This is a remark for me, which I have forgotten to integrate. And so this extension, integrate user token into REST route, is something you can think about, but which is completely optional and can be ignored as well. So ignore it. Some other thing you should support, of course, is these are all REST GET calls. So you don't provide any specific input aside which sensor to choose. And of course, we also want to support something where we provide some kind of data. So there needs to be one URL path that supports or that triggers a specific post call, and where you provide some kind of data to the system. So by calling the URL, you provide some form data in form of XML, and this is then used in the results. And of course, for the environment data, this would make sense that you provide perhaps that only the temperature is randomized, humidity is always the same. And then you can use these post mechanism to change the humidity to a well-defined value, for instance. That would make it easier for me to check if you support this post mechanism. And then, of course, you need to integrate this REST-based environment data server into our overview servlet and realize the fourth server technology in our set of servers we can trigger. So after that, we are able to communicate with a C++ server, with an RMI-based server, with a SOAP-based server, and with a REST-based server. And that's basically it for the exercise. Right, for the dummy data, I can show you a small example before we take a look. Let's see. We go to, oops, nope, I didn't start that one up. I have to close this one. Close and start up XMPP, start Tomcat. Because we want to use Tomcat localhost 80, waiting for it to start up. This will take a second. There you are. We go to app management, surprise. And then you can already see how to deploy a REST-based web service, which is again using WAR archives and using webinf directory. So that's basically it. Install. After that, this becomes available. And now, can I remember that? Was it test? Yes. So this is calling a REST-based web service. And as you can see, test is the default. I can say, give me something in XML, then I get something in XML. Give me something in JSON. JSON will be provided. Did I also provide plain? Yeah, plain is also available. So this is what happens. So I can manipulate the URL and then choose different methods in my REST-based web service. And we can take a look at that. And we can take a look at that. We can close all, go to that path. So this is the class we're currently looking at. This is the default approach. So we have annotation again, telling it, okay, you are reachable from the servlet perspective and this URL attachment. And then this pops up if we use text plain. This is what we are seeing here. if we use the path plane, we get this one. If we use JSON, we get this one. If we use XML, we use this one. And of course, we can integrate additional ones. So we can either choose which method to call by providing a specific URL path. But as I already told you, we can distinguish based on what is necessary. So what the client is capable of understanding. So there are additional annotations we will take a look at in a moment that specify, okay, if the client only understands plain text and does not provide a specific URL path, then we should use this method to provide the data. And if the client is capable of understanding JSON, then we should use this one. So the name of the method is completely irrelevant. It's interpreting, okay, what is the client that is calling this web service capable of? And that's basically what is done. So we can use curl. We can use curl, and a small example here. So we could tell by using this command here and just piping it here, we can say, okay, I want to, let's not aufräumen here. And then we can, what do we say? We use curl, we tell to provide an accept header and tell the system that we are capable of understanding XML, and then we call the REST service we just integrated. And by doing that, we get an XML reply because we said we just know XML. We can understand XML. And of course, we can do something similar by telling the system, okay, I want to use the web service of you and I understand JSON. And then I understand JSON. And of course, plain text is also available. And these are the possibilities, or some very simple possibilities to use the REST-based web service. And as you already saw, REST-based web services are deployed through Tomcat, and in the background there is a servlet running, but we don't see that anymore at that point. Right, let's see. What do we need? Of course, once we have this REST-based web service up and running, we need to set up an HTTP call inside our Java program to integrate this REST server into our servlet. And of course, there are, again, multiple APIs possibly usable to set up a HTTP request inside a Java program, get the result, serialize the result, and bring the result into our system. The slides provide the approach using the Java HTTP API. And yeah, what we use inside this HTTP API is the URL class and the HTTP URL connection and some methods that are available. So which kind of request method do I want? If I want it streamed, if I want fixed length, some properties if I wanted to. So what I already did with curl. So if I want to manipulate the HTTP header, connect stuff, get data, stream data, check what the length is, and so on and so on. So there are quite a few classes available, which we can then use to generate our input. And the scanner is also used in the example, but of course you can choose whatever mechanism you are already fond of, or which you find in SourceForge or Google, or you can use what's provided in the slides. And that is definitely working because it's tested thoroughly. So you can decide that. So this is how to send some data to call REST or call a web service and also provide some kind of data. So that is an example that could be used. So you have the URL, you open the connection, you choose to send a post request. You want to provide some data of a specific size, and the content type is XML. So you want to provide some XML to the web service, and then you get some data back, and then you can interpret what is ever brought back to you. And you can use that in your overview servlet later on. And on the receiving part, so when you trigger a URL, if you wanted to, and then you can use a scanner to extract the data that is provided. So you can open up a specific URL and get the content that is available. So another example how to receive data, and by just issuing a GET call to a web server, web service, web page, whatever you like. This brings us to the REST-based service world. So REST-based web services, the second, currently the bigger or more commonly used version of the web services. Nevertheless, as it is with every hype, it is already degenerating. So it's typically when you have a hype, it reaches a peak and then it levels down quite heavily and reaches some kind of, okay, this is the real usefulness of a specific technology. In the beginning, everyone wants to use it. So as we are currently using, everyone is using artificial intelligence, or everyone is using virtual reality, everyone is using augmented reality. And at some point they realize, okay, it's fancy, but it's not really useful in this kind of domain. And so we choose to use something else. And the next hype pops up, and this is always the case. It's always the same. And at some point it levels out to a useful amount of use cases. Same goes for REST-based web services. So the REST-based web services, the documentation states it's more like, it's not really a service, it's more like an architectural pattern. So how to structure the web, the content of the web in a very simple but very consequent way. And this is basically the idea. So you reach specific resources through the call of unique URIs, and this content is described in a specific format and gives you the ability to reach sub-elements and stuff like that. So the whole network is a huge graph that is interconnected. And this REST technology enables you to communicate, to work with this graph that represents all the knowledge that is available. And yeah, that's basically the idea. And you can reach specific resources through the use of URIs, and then you can exchange or extract the knowledge that is contained in there, use that in your services, manipulate the content, move forward from this content to some sort of sub-content. And that's basically the primitive idea behind that. So REST-based web services are very, very, very simple. You have just connected data, content, properties, and a specific way to trigger this content. And again, this is stateless, and this is quite typical for the web technology. So you have the ability to get some kind of data. You can post, manipulate something. You can put new nodes into the graph if you want to. You can delete nodes in the graph and stuff like that. It's quite heavily attached to the HTTP protocol, which is quite easy to use and used everywhere in our modern world. Aside from that, resources can be nearly everything, data, content, scripts, whatever you like, definitely. It's not really restricted to anything. Aside from the structural and the syntactical structure, everything is more or less possible to be used in this kind of world. So when we issue a specific GET call, just as we saw it in a minute ago, you get an HTTP response with what you are really interested in. So a specific trolley content, your shopping content, what you did, and inside these contents, again, we have different other possibilities to continue our mechanism. So you get a specific toothbrush and you can follow a specific link and then get more information about this toothbrush if you wanted to. And of course, we want to build something like that. And as we are playing around heavily with Java technology, we are using JAX RS, not WS anymore, but RS, which is the default implementation for the REST-based web service world. And that's basically what we will be doing. If you stumble upon this name Jersey, that's the reference implementation of the system. It uses Surflake technology in the background. We don't see that anymore, but nevertheless, it is available. What do we need to build a REST-based web service? We need a Surflake container, as they're using servlets, and some APIs, libraries we need. These libraries I already provided, so you don't have to look them up. And then the workflow is quite easy. We create a RESTful Java class. Namely, we annotate a Java class with some specific annotations. So we enrich a already existing Java class with annotations. We need a deployment descriptor. So this technology still uses a deployment descriptor. So we need a web XML. Nevertheless, it's not difficult to describe. Then we create a WAR archive, then we deploy a WAR archive, and then basically the REST-based web service is available and up and running. So we need plain old Java classes. We can use interfaces if we want to. The REST aspects are marked with annotations. Important is that we derive ourselves from the application class. So most of you should know the application class from Android, but of course this is a different application class. Nevertheless, it's directly stated the same. What we need is some annotations. One of the most important annotations is the path annotation, which can be used to specify which URL is targeting or pointing at this class, this REST class. So that's the root of everything. And then we can specify path extensions to specific methods. And what we can see in the example is, so this is deployment container web service as the path of the class plus this path extension will then lead to this method or class, whatever you use. We have the ability, so this is hard-coded. And if you find something with these curly brackets, this is free to choose. So hello and John Doe, this is the German equivalent to John Doe, needs this John Doe, could be Jane Doe or stuff or foo. It doesn't make any difference. Always this path would be chosen. So this is a free to choose path element. Path parameters are also possible. So this is attractive regarding this flexible path here. So this is freely to be chosen. And if you want to use this variable inside the URL, you can use the path parameter and use the same naming convention is not right. The same name here, the same ID. So this, what is inside the curly brackets, is a variable name, and you can move this variable name to the method that needs to be called. So this name, this text inside the URL is put into here and therefore moved into this variable here. And in the early days, I didn't have this environment example. I had a beer shop as an example. And therefore, this is also a quite old text code fragment because it still has the API of the beer shop, which was the first example. So this is a get call. The path is something before price for a specific beer. The beer gets dropped into this method call, and then you can check your database. Okay, what's the beer price for Jever? And then you realize, okay, it's 10.99 euros. So, and then you generate an XML 10.99 XML content and send that backwards as a string, because it also says here that this method produces XML output. So that's basically the idea. What you could also see is this is a get call. And of course, if there is a get, there is a post, there is a put, and there is a delete. And this, of course, is post, where we get some data, values, and then you see that the data is dropped into this content here. So that's another possibility to integrate data into your server side, either by using the URL mechanism or by using the post HTTP request. And then everything inside the post content area is dropped into this data. Then you can analyze data and define whatever you want. So XML is put into the method and plain text drops out of this method. Basically, yeah, producers, we already saw that there are quite a few producers available. Only JSON is not text. It's always funny that they changed the naming convention. Did never set that straight. Same for producers is true for consumes. So what the method is capable of interpreting and wants to receive. So if you put some data into it through a post call or through some, typically through a post call, the URL stuff is typically not very fancy. So this is relevant for if you provide some kind of post calls. So how does a REST-based web service look like? Simple. You have a simple class, you extend it from application, you tell the system which path is relevant for this web service, and then you just annotate the methods that should generate the logic. And then basically that's it. All you need to provide is a deployment descriptor, and after that, everything else runs automatically. So what do we see here? Plain text provision. The other one was the default provision HTML, XML provision, JSON provision. Yeah, nothing really extraordinary. So this is everything that is necessary to be constructed on the server side to code. Now the next or the last step is deploying the web service. Again, this is using servlet technology in the background. So what we need is a deployment descriptor. I haven't tried out using the web service annotations. That would be interesting if this works. Perhaps I try that during the exercise. Nevertheless, if you don't want to experiment, you need a deployment descriptor. So the web XML file, and this needs to reside on the just below the webinf directory at the same level as the classes and the lib directory. So, and your code, your class file of your code, it goes into the classes directory, and all the libraries necessary to support these REST web servers go into the lib directory. There are quite a few, so put them all in there, and then it should work. That's also the reason why this WAR archive is so big, even for a small web service. And the last step is that you need to provide the content of the web XML file, and the web XML looks like this. And all you need to do is exchange the servlet name, and the rest runs automatically. So it's not really complicated. You just have to state what the name of the servlet is, and then that's basically it. You build a WAR archive, you deploy the WAR archive, and then the web service is up and running. And then everything else works as always. And that's not really complicated. If you did that with the servlets and with the if you did that with the servlets, you're capable of doing that with the REST-based server as well. So after that, we have a REST server running, a SOAP server running, the RMI server running, the C++ server running, and all the data that is provided by these 4 servers is showing in the servlet, in the environment servlet. And then we have everything at hand what we wanted to achieve inside this exercise and inside this lecture. Right, this brings us to an end of this content. The rest is appendix, so not relevant for the exam, and just some background information how to deploy it, especially the REST-based and the SOAP-based web service, not using the simple mechanism from Java, the endpoint class, but using also using Tomcat as a deployment platform. Right, okay, thanks for your attention, thanks for listening. I will close the lecture call in a moment or two, and then open up the respective group calls. Okay. See you in a minute or two, or at least most of you in a minute or two in the exercises for automotive computing. See you on Thursday. Bye.
Thanks, bye.
Bye.